So yeah, welcome everyone. Really glad that you could join in on this online format, like of course due to the circumstances that pushed us in this direction, but it's something that we wanted to do for a long time anyway, so here we are. So as usual, we always looking for speakers at Software Circus. So we are continuing our agenda. We are obviously moving 100% online. So that doesn't change. If you have talks, if you know someone who knows, if you know someone who is willing to talk and has a talk ready, or is interested in starting, just contact us. That's all the information that you need to reach us on Meetup, an email, or directly on Twitter. You can find us quite easily. Let us know, and we will arrange something. So without further ado, it's time for the two talks that we have planned for today. The first one is about serverless. Is it just cloud native duct tape? It's actually an intriguing question. And the second part will be Inspector Gadget and Trace Loop BPF debugging tools for Kubernetes. I wish you everybody to enjoy these awesome talks, and I'll leave the floor to Christian for the first one.
Hello. Let me just share out my screen. I hope I've got the right one. That should be the right one. Does that look correct?
Looks great.
Awesome. Hello, everybody. I'm Chris, full name Christian, but just Chris. And you can find me at Chris_coding on Twitter if you've got any questions or anything regarding some of the topics. Yeah, and this talk is about whether serverless is just cloud native duct tape or whether it actually has a place the same way as Docker does for us today. A little bit about me. I am a cloud native engineer at Container Solutions. I immigrated to Germany in November, and I come from a software engineering background, and I previously had the title of DevOps engineer. I am originally from South Africa. I used to build furniture as a hobby, some wood and steel stuff, and now I just play Ark. Some Ark Survival in my free time because I don't have a garage in Germany, because that's apparently not a thing. So today my talk is about serverless. It covers the topic of Lambda, but that's only the delivery mechanism. The practices I've basically seen have been across many serverless ways people use it. Yeah, and the reason I use Lambda is because most people have heard about it before. And also because a lot of my frustrations with serverless at the moment come from how people use Lambda mostly. So the original idea behind Lambda looked something like this. It was meant to abstract away the OS and the virtualization and that sort of thing and leave us with runtime as config. And all we needed to worry about was our applications. I believe this idea is good because managing servers is a pain. Security patches are a pain. We don't want to do that. But more and more today, what I'm seeing people use serverless for, it looks a little bit more like this. So people have, for some reason, broken down their applications into 100 different Lambda functions instead of using Lambda for the original reasons, which was OS and virtualization thing. And they mistook loosely coupled architecture and built disparate systems. And also people are using Lambda as duct tape to fix things in the cloud, to extend the clouds in some cases, but sometimes to fix the things that they can't do. Some of the things I've seen is that seen people use Lambda to add steps for distributed CI/CD, ad hoc things like running my database migrations or updating configs because they couldn't get access to, for instance, their VPCs from their CI/CD systems. I've also seen people distribute their Lambda functions in a way where they moved HTTP validation logic into API gateway rather than it being contained in what they were building, which is where they need the validation to change. And then they move all this validation into API gateway, and then they complain about vendor lock-in where it's really hard to move away from API gateway, which is strange to me. And then one of the most recent cases I've seen was data synchronization between legacy systems and modern microservice-based systems. So they would do some data stuff and then push those back into their legacy system so the data doesn't get outdated. And as a result of this way of thinking about Lambda, a few things have ended up happening. HTTP services, just REST APIs, have started feeling like disparate parts of the same thing. It's meant to be the same thing, but it starts feeling like all of these distributed things. And people have started pushing more focus into integration testing to make sure things are working. So they push all of their Lambda into AWS and then test through API Gateway to make sure the functions were working. And that's how they confirm their deployment works. And your services become a whole lot less cohesive and actually harder to manage because you've got all of these Lambda functions and distributed things. And that ends up in people overusing event sourcing to manage communication and triggers for all of their Lambda functions. Lambda is meant to be event-driven. It's sold that way. It comes with that sticker, but I've seen people start overusing event-driven architecture to make Lambdas work and not using event-driven architecture for what it's meant to be used for. And as a result, all I can see is late nights, 4 a.m. wake-up calls, Lambda's broken, and then a lot of frustration trying to fix those Lambda functions in production. So getting back to what serverless was meant for was for OS and virtualization abstraction rather than this distributed thing in the cloud. And what's ended up happening is sort of looks like this. So people have started breaking down their services into hundreds of different Lambdas that do little tiny things. Some have used a single layer for dependencies and then multiple small functions for their business logic. And that ends up in a whole lot of sprawl, and you've got this weird thing with orchestration and a bunch of orchestration. And in order to test, you end up using events to trigger other functions, which trigger functions to make sure everything works together. And you need to do that in the cloud. And there was no need to separate them if they were used together. They're part of a single unit. So some had dependencies per function. So some would include only the dependencies that that particular function needs. And that would just end up in a whole bunch of different package.json files. And it started feeling like this whole disparate thing, which was actually meant to be just one thing. And in both cases, you end up with a lot more management and no real benefit to your overall architecture. You do get the benefits of Lambda in terms of not managing architecture, not managing servers or VMs or OSs, but you introduce a whole new line of complexity, which again slows down execution. You've got this version skew thing where one function and another function need to move together, but they need to be deployed together, and it just becomes a whole lot more hard to manage. And to me, it starts feeling like that's the reason a lot of people don't consider serverless necessarily a replacement for things they do today and the way they use things today, but as duct tape to extend what the cloud could possibly do or does. Instead of using it as a replacement to get rid of VMs, they've used it as that. But that's not what serverless promised us. Serverless promised us no server management, some auto scaling stuff where we didn't worry how they scaled it, but it scaled, and letting us pay only for executions. So we didn't have to manage anything. But this doesn't necessarily mean our code needs to become less cohesive. Our code could still be part of logical units, but it did end up doing that anyway. And the end result of serverless was meant to be faster time to market by letting us worry about business logic rather than orchestration or security patches, server management, that sort of thing, and simplifying what we needed to do for us to build services. But the sprawl adds a whole new line of complexity, and we can't reach the real benefits of serverless with the sprawl in mind. But there is hope. So I found hope in a piece where this is what I saw. And then there was a little bit of hope. So it comes in the form of Laravel. Now, Laravel is a PHP framework created by Taylor Otwell. And the framework as a whole makes it a lot easier to build out applications. It's got some boilerplate stuff in, which is already baked in, so authentication, caching, databases, models, all of that sort of stuff. And you can worry about building applications. But deploying a Laravel application is a whole different paradigm where you actually have to manage servers. At Loricon US, Taylor announced a product called Laravel Vapor. And at its core, it allows you to deploy a fully fledged Laravel application into Lambda, connected to RDS and SQS and sometimes Aurora, and a bunch of other AWS services, keeping the exact same application, not needing to change any of the application logic. You can focus solely on building what you're building and not worry about how the cloud does its thing. Now, I didn't want to necessarily build out Laravel applications and deploy them into Lambda, but I did find the idea of how they were deploying it quite interesting. And this gave me, this inspired me a little bit. So what if I could build fully fledged microservices in Node.js or Python and deploy them in exactly the same way? Not worry about orchestration, but deploy this full thing into Lambda and just reap the benefits of no server management. Now, building a microservice which contains all of the logic which belongs to it, and then use serverless only as a method of getting it to the real world. And avoiding lock-in in AWS as a whole, because you can run the service locally and run all of the parts locally and not need to worry about how AWS does it. Obviously, there will be some testing involved to make sure local matches cloud, but it becomes a lot easier. And we don't use the cloud in its way in terms of adding validation to API gateway, but rather use the technology underneath the cloud and use it in a way that makes our lives easier and helps us bootstrap our businesses faster. And I could immediately see a whole list of benefits to the approach, which previously maybe weren't possible or maybe I didn't think of. And services become equally cohesive to how we use them today in Docker, for instance. We have a Docker container which contains an entire microservice, logically separated by teams or context or domain or however you separate your microservices, and just deploy them into Lambda. They become a lot easier to develop locally because you've got Docker and you can run a database locally. Instead of using some weird testing mechanism which acts as local Lambda, where local Lambda you don't need to use Lambda to trigger functions and functions. It's all part of the same code. It becomes a lot easier to unit integration test the whole solution, especially when you work offline. And then testing is not tied into the cloud to see whether things work, because code calls code and not code calls Lambda calls code or code calls event calls code. It's code that calls code. All the code shares a single cold start if you do it this way. So no matter which endpoint you hit first, all requests are warmed up after that. If you use some sort of provision concurrency or that sort of thing, but all requests are warmed up immediately. It's not Lambda by Lambda by Lambda. Provision concurrency becomes a lot cheaper because you only provision concurrency once for one Lambda function. It simplifies the whole solution, and you share connections to everything as well. You don't have 100 Lambda functions all connecting to the same database. You have one Lambda function connecting to the database, and the endpoints will scale those Lambda functions up, but only that one Lambda function scales up. So you're using the cloud as a mechanism to reach your users and not as part of your actual solutions. So you're using, for instance, API gateway, not as a routing layer, but rather as a reverse proxy layer. And that makes it a lot easier to, for instance, swap or interchange, or if you find something better later on or something cheaper you want to use, it's a lot easier to swap because it's essentially just a reverse proxy. And this boils down to putting your code in one Lambda function with its own logic and its own rules, rather than splitting this thing into 100 functions. And this lets us focus on building great businesses and not have to worry about managing all of this stuff in the cloud. So this is where I started. With this idea in mind, I started researching some stuff to go and see whether it would actually be possible, whether it'd be viable to do it this way. So the first time, just Lambda, hello world, default Lambda function to see whether it works or not. Very easy, very simple. Now that code looks very nice, but it's not a service. So I wanted to use a micro framework which has some routing in it, some middleware and some cores. So I decided to use Express.js. So I checked out how to add node modules, because this was in the AWS UI. So I would go, oh, how do I add node modules to this? And then I got slightly frustrated. So the result is that you have to zip up your function with its node modules and the source code, and then put that in S3 and point Lambda at S3. So you mean to tell me I need to upload my code as a zip file? When we used to upload in PHP using FTP, people wanted to put us in front of a firing squad. And today we use FTP or zip files to upload our code to S3 and tar zips to upload Docker images into Docker Hub, and no one says anything. Everything's fine, right? So FTP, you ought to be ashamed of yourselves. Anyway, the next thing was making sure that the Lambda actually works. And what I wanted to do was just invoke it and see some log data to make sure it actually worked and didn't just lie to me, because I've got that insecurity, I guess. So this surprised me a little bit that a Lambda function doesn't by default come with a place to log to. You've actually got to give it permission. Now, this came as a surprise at first, but it does make sense in terms of moving where you want to log to, if you want to log to the same places, that sort of thing. So it wasn't as surprising as a zip thing, but it was still surprising nonetheless. So I started declaring some stuff in Terraform. So I created an S3 versioned bucket so that I could upload my code and version that, and then use the version for that to deploy my code. So uploading to S3 wouldn't break whatever I was building. I could slowly introduce changes as I was going along. And then in order to upload my code, I added this beautiful scripting to my package.json. Very, very cool code. Took me super long to figure out. But essentially, there's 3 scripts. There's a package script which zips up everything. There's an upload script which uploads it to S3. And then there's a get version script which will go and fetch the version for me, for my function. So I could include that back into Terraform to update what was running. The deployment was also fairly easy. I'm raw for Lambda in Terraform. And then it's not shown in here, but the Terraform resource for the Lambda function just refers to a version in an S3 bucket. So if I want to deploy a new version, I just update that version and then do a Terraform apply and everything works. The next step was to expose the Lambda function through API gateway. So I could actually call the service from the outside instead of clicking a button in the AWS console. And then I could probably CNAME that at some point or find some way to add a custom domain to it. I did set up an any gateway method with a proxy through to the Lambda function. I don't show the actual API gateway resources here because I'd need many, many slides, but there are quite a few of them, probably built for how people are using it now rather than just as a reverse proxy. That's probably why there's so many steps. But for the reverse proxy method, I basically just one-time deploy and I don't need to touch it again. It just keeps on working. You also have to allow API gateway to invoke your function. So this is that resource in Terraform. So by now my function is callable from the interwebs. It's running correctly. It's responding to requests. So now it's starting to feel a bit more like a service. So this is now an Express.js service. It can log some data. It's got code. I can redeploy it, and it's externally accessible. Now, by default, like I said, CloudWatch doesn't have, or Lambda doesn't have permission to log into CloudWatch directly. So you have to set up these resources. They're essentially just a log group and a policy which allows the Lambda to log to that log group. And then attaching that policy to the Lambda role. So now we have all of this stuff. Express.js, we've got S3, CloudWatch. So now we're starting to feel like a service. So at this point, I needed something to aim for. Otherwise, I'd probably get bored and not want to do it anymore because I'd already won. I couldn't lose at this. So I needed something to aim for. So I built this little UI in InVision really quickly to go, cool, you've got libraries and you've got images in those libraries and you can do a bunch of stuff. Probably procrastination, but it was still good. Then I moved on to building this actual UI, and this is what I ended up building. It's pretty, right? Pretty cool. I think it was beautiful. But it does serve the purpose it was built for, and it shows the different pieces of functionality I needed to make this product work and integrate all of these different parts I wanted to work together. So it has buttons for most of the authentication stuff. Usually in an app, you sign up to logins, logouts, all of that sort of stuff. It has a few buttons for checking where the API gateway actually authenticates the requests through to the Lambda function. And it's got a database aware endpoint, which is make sure we can do database calls, a background tasking endpoint, which would just spin off a background task through SQS and back to that same service. I'll explain that at some point. And then a place to upload files into S3. So that would make up this whole service. That would allow me to build this entire thing with this Lambda thing. And there's actually a quote that says, if you're trying to teach a monkey to recite Shakespeare standing on a pedestal, you probably wouldn't start with a pedestal. You'd probably start by trying to teach the monkey how to talk first. So this was my monkey. This is how I was going to prove that point. So here's a few things I learned along the way. When you use API gateway as a reverse proxy, you actually got to know about that little proxy plus thing. And you set up 2 paths. You've got flat path, a root path, and then you've got the proxy path. So it would forward everything with the endpoints the right way. And in Lambda, it would end up as headers in Express.js, which is pretty easy. And then another thing was that if you want to expose certain endpoints or certain methods for guest access, like for instance, passing through cause options, then you couldn't use the any method on the gateway anymore. Because in AWS API Gateway, any precedes any other methods. And as soon as it matches any, it would bounce off the authorizer and then jump out again. And you can't change the ordering. So you can't put options requests as guessable endpoints to pass through options requests so that you can do pre-flight checks against your own service. So you actually have to register every single endpoint or every method, but that's fine because those only change like every 20 odd years. So that's cool. I wasn't too worried about that. And this allows you to do any proxy parts. And then also when you've got guest endpoints, you can specify the specific guest endpoints. So if you've got an about page or something, you can specify those, and those would override whatever you had, and then pass those through as guest. There is a new API gateway called REST API, which is currently in beta. I haven't looked at it too much, but it sounds like it was more made for this case. Authentication was also easy starting off with. Cognito was pretty easy. There's a couple generic options which become a bit difficult, but it was fairly easy. The options were between Auth0 and Cognito. I chose Cognito because it's just really cheap. You can have 50,000 users free. And by the time you reach 50,000 users, I do hope you're making money. I sincerely hope so for you. So that was a pretty easy Terraform thing. I did set up a Google Auth provider just to test it out. I used the hosted UI at some point just to test it. There was no plan to use that in a production system because that might be a bad idea. But then I started integrating this user pool into the API gateway, and that's when it became a bit strange. You've actually got to do resource servers and custom scopes in order for API gateway to bounce requests. Otherwise, it just passes it through because for some reason. But it would just pass it through. So with the custom resource or the resource servers and the custom scopes, you can give it a custom API scope and then limit the API gateway to that particular scope. So everyone who logs in with that scope can then reach your API, but also get bounced if they're not logged in. So you can use API gateway as an authentication mechanism as well, part of the reverse proxy. And then on that front end, I used the Amplify library just to plug into that because it's got everything built in. I do have a gripe with this, as there's some things I don't agree with, like refresh tokens, but that we could talk for hours about that. The next part was obviously integrating the database. So that was inside a VPC by default. And it took me a while. From local, I couldn't access the RDS database once I spun it up with RDS. I actually had to update the security group with my local IP. So that was fine. I accepted that. That was cool. But then I was wondering how to do that in Lambda because I don't manage any of the infrastructure underneath, and Lambda is going to move around a lot. And eventually, you just have to add the Lambda. You have to add the database subnets of the subnets that the database runs with to your Lambda function and associate with the same security group so that they're in the same VPC essentially, and they can talk to one another. So that eventually got set up, and I could run some migrations. I could do some database calls. That was pretty cool. That worked. And then was the next part where I wanted SQS to work, but SQS doesn't fall within a VPC. It falls outside of VPC because it's an internet accessible service, and which means I couldn't reach it to the outside. So after a bunch of Googling, someone said like NAT gateways and routing tables, and I just thought, no, I really don't want to do that. And the end result was just a VPC endpoint to let that out into SQS. So now we've connected to everything. The one thing I do want to mention is that everything we've done up to this point has been absolutely free. You could do 1 million invocations. You've got 20, I think it's 2 or 20 gigs of data free in RDS with a certain amount of connection limit because you're using the micro VMs or the micro instances. But everything's been free except for this VPC endpoint. It's not massively expensive, but it is the most, compared to being free, it is infinitely more expensive. So it does cost money there. And the next part, the next little weird part was just the storage integration. So when I wanted to upload files, it didn't make sense to upload them into Lambda and then through to S3, because that would be just double network hop. But you do have this pre-signed URL thing in S3 where you can pre-generate a post request or put request to S3 and then pass that URL back to the front end, and it uploads directly into S3, which is pretty useful, I think. Yes, it is. It feels a bit hacky sometimes, but it works. So after all of that, some of the takeaways I've seen with taking this approach, because this is how I now want to deploy all of my stuff. is that high scale might become an issue later on, but that is across the board because you can only have 1,000 concurrent invocations of a function. And then code size might become a bit larger, especially when you add packages and packages and packages on top of one another. But if you layer them correctly, then you're going to be fine. Then it sort of works like a Docker image as well, where you have these layers of things and only the parts change that need to change. You're probably going to end up having multiple duplicate functions with different handlers. So you'll have one handler for your HTTP service, you'll have one for your queue handler, you'll have one for your console commands, which you can run ad hocly, and you'll probably have some to run some CI/CD stuff, the duct tape part of serverless. And then you will lose some of the cloud functionality, like, for instance, the API gateway documentation, which it generates when you register routes there. But you do gain lower migration costs by not using them. And then I haven't considered yet step functions, which might be weird with this approach. And then custom execution environments, for instance, PHP underneath. In order to run PHP, you need to build a custom execution environment. But overall, the solution ended up being really simple. I could execute really quickly and add endpoint after endpoint after endpoint after endpoint and merely update Terraform and deploy it. It was really, really easy to get stuff done. I didn't use serverless framework. I didn't mention that somewhere, but I did not use serverless framework, merely because I disagree with some of the stuff they do, but not overall. They do have a good solution. Nothing bad about their solution. It just wasn't what I was trying to achieve. And then time to market becomes a whole lot faster because I can iterate so quickly on one service, run tests locally, which doesn't need to run in Docker or anything weird. I could just run them and they're super fast. And then I can just upload that. And then with this solution, I found that there's very low lock-in and the migration costs are super low if you ever want to move away from this thing. So to answer the ultimate question, for me, is serverless just duct tape? Yay and nay. It is duct tape in terms of when the cloud providers only built 80% services, then there's parts missing that you really need, you're probably going to have to use Lambda to fix those instead of running VMs or that sort of thing because of how the event triggers work. But it could also be used to deploy microservices and not have to manage anything. So if you're building simple services like this, where it's an Express.js service, which is a REST API to a database and an SQS queue. And you could actually build fairly big things with this, but it becomes a whole lot simpler to do that. And managing Kubernetes, for instance, to run that with is just makes no sense if you can do it this easily, unless you've got some weird native dependencies or that sort of stuff. So I haven't shown any code samples, but I have uploaded them. You can actually go and look at the service I've built over there and the infrastructure over there. It's under /racklessness. There's just some repos over there. And then you can reach out on Twitter if you've got any questions when looking at the code or if you've got any questions regarding the way I've done things. And then on Twitch, I'm lone_developer. I'll be doing some streaming over the coming weeks about the serverless stuff and building some SSR applications in serverless and deploying them at Edge and that sort of thing. So yeah, enjoy.
Well done, Chris.
Thank you.
So does anyone have questions?
Thanks.
Come on, don't be shy if you have questions.
Let's see what the people are saying here.
Well, Bart says, great presentation.
Yeah, see, Tristan's asking if the slides are available somehow. I will publish them afterwards. They're pretty easy to publish. Yeah.
All right. Awesome. Well, thank you. I think, yeah, there's not any more questions coming up. So, no, really well done. It was like even I understood, and everybody knows I'm not an engineer. So, like, yeah, really.
Thanks,
well
everybody.
Oh, there's one coming in on an S3 instance.
On an S3 instance? Oh, the slides? Oh, publish them on an S3 instance? Probably, definitely not.
All right, very cool. All right, well, then it's time for Alban to present us his own talk. Again, thank you very much, Chris. It was really cool. So yeah, Alban, the floor is yours.
Thank you. Can you hear me okay?
Absolutely,
Okay.
can hear you fine.
So I will share my slide. Okay. So I will talk about Inspector Gadget and Trace Loop and how to debug your application in Kubernetes with BPF. My name is Alban. I live in Berlin. I'm a CTO at Kinvolk. And Kinvolk is a company that cares about Kubernetes, Linux, and we both provide support on our Linux and Kubernetes distribution and do consulting work on different parts of the system. Today, talking mostly about strace. I cannot see everybody here, so I don't know how many of you have used strace, but I really like this tool to debug my application. And that's a bit difficult to use on Kubernetes, and I will talk about that, how we can have strace to debug your applications with BPF. So the first tool I'll talk about is Trace Loop. That's to trace system calls in a similar way to strace, but using C groups and BPF and in a different way. And then Inspector Gadget is like using Trace Loop and other tools to present that in a user-friendly way on a Kubernetes level. So that's two open source projects. So this is using BPF. I will not explain BPF in general, but just in a nutshell, when you have a BPF program written in C, you can compile it to the BPF pseudo architecture and then upload it in a Linux kernel to execute it. So that's BPF is like a mini VM running in your Linux kernel. And from there, you can attach it to different events like network packets or system calls or different things. They can be used for tracing, networking, but here is this talk I focus on tracing to debug your applications. So I mentioned a few problems I have when using strace directly in Kubernetes. First, it is slow. I don't mean that in a bad thing, but it's just not possible to strace all your process, all your applications on all your nodes in Kubernetes. That will not work. That will slow down too much. My typical use case is I have a pod crashing, and then I think, oh, I wish to know what was the last system calls executed by this pod, but then it's too late when the pod has crashed. It's too late to go on the node, type strace to the process because the process is gone. So the idea is to have a fly recorder feature, a bit like in planes. It records everything in a ring buffer, and it's a overwritable circular ring buffer that record all the system calls. And then when we actually want to debug something that has crashed, we can look at the last events. And that's what I will present. That's what a trace loop is about. It works in a different way than strace. Instead of using ptrace, it uses BPFs and trace points. Strace is has a focus on processes. You can attach to one or several processes. Trace loop is on C groups or containers. Strace is slow, but it's reliable, and trace loop is fast, but might sometimes lose events in some case. And you only get the last events from the ring buffer. How it works? I use a BPF program on the transparency center here at the top. That means that every time the system will execute a system call for all the process, it will execute this BPF program in the Linux kernel. And then we look at the C group. Depending on the C group, it will identify which pod it is coming from, and then store the system call in a different ring buffer. Those ring buffers are not read unless the user specifically asks for it. For example, when something crashed, the user can look what was the last event in that ring buffer. then the events can go to user space through BPF maps. I will first do a quick demo of trace loop, and that will be a demo without Kubernetes, just on a Linux system. I think I need to share my terminal here now. So let me do that right now. Okay, so trace loop is a command line tool. Here I will execute this command that says I want to record everything that's happened in this C group. Here that's the C group of the SSHD, so the SSHD mode. Now it's recording everything. I will go to a different Windows and I will do some SSH command. Okay, so now I did something SSH. As you see, I don't see anything in the terminal because it doesn't print anything from the ring buffer unless you ask for it. And then when I press Ctrl+C here, I should see the last few system calls from the everything that is in the SSHD C group, so from SSHD daemon. Okay, I prepared a second demo. Sorry. Here I will start a new systemd service, and in a different Windows I will record everything that happened in that systemd service. So nothing happened so far, and I will execute some command here. And when I press Ctrl+C here, I will see the last few commands executed in my bash and my shell session. So I can see here the last system calls from bash and BC and whatever I executed in my shell. So that's my demo for trace loop, and then we will see how to apply that in Kubernetes. I will share my slides again. So far that was a CLI tool on Linux, how to adapt it in Kubernetes. In Kubernetes, we typically don't really care about individual processes. The granularity for tracing is the pod, Kubernetes pods, deployment, and so on. And we care more about Kubernetes labels. We want to address pods by labels and have a user experience similar to kubectl. So developers should not need to SSH on individual nodes, but they use a kubectl-like command to select a pod or a deployment. So here I show some few Linux tracing tools using BPF, BPF trace, BCC, trace loops, and other. And on the right, there are some Kubernetes projects like kubectl trace and inspector gadget that use those Linux tracing tools on the Kubernetes level. And the way it works usually is something like that. When you are on your laptop and you develop your application, you don't SSH on a node, but you always go through the Kubernetes API server to create a Kubernetes plus class object like pods or jobs and so on. And then things are executed in a pod, and the BPF programs are executed from that pod. Now it's time for a demo on Kubernetes. So let me share my terminal again. So here I prepared, I have a Kubernetes cluster running with some pods. On the demo I want to prepare is just running a new pod that with some shell scripts that has some bugs. It doesn't really work. But what I want to demo is even if I delete that pod, I will still be able to debug what was the problem with that. So I use this tool, inspector gadget trace loop list, and I can see the list of the last few traces that I have. And I see I have a pod that has been deleted 17 seconds ago. That's come from the pod my demo. So I will show the integration with trace loop here. I will take this trace ID, and I can see the last few system calls that has been executed. So I see the program BC was executed, the shell, and so on. Okay. Let me go back to my slides. So in this way, I could use a trace loop and see the last system call of pods. Inspector gadget actually has other gadgets. Trace loop is one of them. Another one to create network policies on some tools to debug TCP connections, and so on. My demo was done using Flatcar, that's Kinvolk's Linux distribution on Locomotive, which is our Kubernetes distribution. I use those because it has it's a version with the last kernel version and the last tools I need. I tested it on others. Sometimes I need a newer kernel version that are not available elsewhere, but as an open source project, patch are welcome to make it work on other platforms as well. In the end, it used Linux technology like cgroup version 2 and so on, BPF, which is nothing specific to Flatcar or Locomotive, but there is additional work to make the integration happen. The gadget I have, some of them are to debug your application, like trace loop, I just demo here. Some to inspect what are the files being opened by different ports, what are the programs being executed, and what TCP ports are used, and so on. One gadget is about network policies, so it's the use case. I will demo it quickly later. That's a working project. Some gadgets are already written, some are work in progress. Okay, time for a new demo. This time I will demo I have an anti-pattern here. I will execute this curl pipe sh command. To usually that's not something we should do, but here I want to demo how it is possible to debug what's happening in that pod when it's not so obvious because the source is not directly visible. First, I will use this exec snoop option. So if you see, I can filter events, the execution of new process based on the pod name or labels and so on. Here I will just say I want to see all the new executions of new process in the pod name called cooking. And in a different terminal, I will start this command. And what it does some things. It's not so obvious what it's doing, but if I go back to the previous thing in real time, I can see the different commands that are executed. So it's kind of give ideas like, okay, I see it's using RPM or it's using different other commands. So I see as opens exec snoop as a tool to debug your application to see what it's doing. Exec snoop is a bit similar. It will show every new file, every file that are open in the pod. But here I'm too late, the program has finished. So I will stop here. So how it works behind the scene, it uses a component called Gadget Tracer Manager. And the goal of that is to provide this feature where I can filter events coming from specific pods. I can filter pods by namespace or the pod name, but also by labels or by things from a specific node, or by container index. That's when a pod can contain several containers, and I want to choose which one to debug. So you can use one or several of those options to select what you want to debug. And sometimes it's not so obvious what is selected because pods can come and go. They are being created and destroyed often. on the tracer, the gadget command I type on the terminal, they can come and go as well. So what you actually select is different one time to another. So here is the central component, the gadget tracer manager that received, its role is to keep track of different containers that exist and different tracers that exist and see how to match them to each other. And it will update a BPF map that's kind of a global variable with listing the different containers that will be traced by each tracer. And that will be used by the BPF program to see, to select what to filter. Now I will continue with a different demo. So this demo, I will actually show you in the browser what it is. So give me 1 second. Okay. I hope you can see this. This is just an example of microservice demo hosted by Google. And it has many different pods and components. And if I show you this YAML file to install, it contains different deployment on different services. But as you can maybe see, it doesn't contain any network policy. So sometimes when I want to add security as an afterthought, after the fact, if I am a developer and I get assigned the task to add network policies, that's a bit difficult for me because I don't really know what is the architecture of that thing. And I could look at the source code and look at the configuration. That's a quite difficult process because I will have to do trial and errors. So here come a demo of the network policy gadget. What it does, I will make it bigger maybe. You run the network policy gadget and it will monitor every new network connections in a specific namespace and record that in a file. So for every TCP connection, there will be a new line in that file. And meanwhile, in a different terminal, I can apply this YAML file containing the deployments. And after everything has been deployed, stop inspector gadget, and from the log file, I ask to generate a network policy. And the network policy will contain, for example, things like that. It will auto-detect that this pod has talked to this pod, and it will suggest a network policy that you could apply to your configuration. Of course, that should not be used blindly. You should think whether it's normal that here the card service can talk to this other pod. But I find it a lot easier to do like that, to generate a long list of network policies and check if things looks okay. Okay, let me go back to my slides. So if you want to contribute to Inspector Gadget, you can go to this GitHub repository for Inspector Gadget on Traceloop. And I created some issues with a good first issues label. What it means is either it's an easier task or it means I can provide guidance if you want to work on that. Inspector Gadget also has a channel on Slack, on the Kubernetes Slack, so you're welcome to discuss things here as well. And that's my last few slides. If you want to join virtual projects, that will be online on the 1st of April. So, thank you.
Thank you, Alban. And there's really a cool talk. We actually have a question that just came in from Alex Sola, who's asking, how does Inspector Gadget impact performance? For instance, when logging TCP connections?
Sorry, I've not heard the last part of the question.
That's all right. I'll repeat it. So how does Inspector Gadget impact performance, for instance, when logging TCP connections? It's in the chat if you want to read it.
Okay. That depends on which gadget is used. So for except trace loop, for all the other ones, first, when you don't use them, that doesn't impact at all because that's there is nothing running. Second, when you run a gadget that monitor files or TCP connection and so on, that's add trace in the kernel, but that doesn't generate much context switch. It's not like trace or anything like that. I've not measured the performance, so I cannot give numbers. But for example, for the network policy gadget that monitor the different connections, it comes from a project called TCP Tracer BPF. And that project is used in WeaveScope, which is a tool that is used to run all the time. So it's the same performance hit, I will say, but that should not be a big hit. And about trace loop, so it is designed to be a gadget that runs all the time to record everything and to be able to debug when something crashed. I have although not yet measured performance there. I will expect it's not too much because it doesn't generate any context switch or passing the message from one process to another. It's just it has the cost of a function call in the Linux kernel when you execute a system call. But sorry, I cannot give more numbers.
All right, thank you. Like Alex, really appreciated your answer. Thanks.
Thanks.
Any other question, anyone? I can give also like an audio voice to people who want to talk. So same question from Tristan. So that was answered. Yes. Oh, slides. Yeah, sure. Okay. We will share the slides as well. Like Alban, sure you can provide them to me, and I'll post them and I'll host them on some drive, and we'll share tomorrow in Meetup. Oh, actually, you already posted them. All right. So yeah, perfect. You were ready. Very cool. Yeah, again, no developer. I don't understand. It's probably a good joke. Like crash dump, core dump.
Crash dump, core dump? I didn't understand the question, sorry.
Like, so Tristan Guess is saying like a crash dump, core dump, but more powerful. It's in the chat at the bottom. You have a chat option if you want to read the question yourself.
I'm sorry, I didn't hear you, and I don't see the questions. I see all panelists and attendees.
Oh, okay. Like at the bottom of your screen, if you hover your mouse at the bottom, you should see like a bunch of options, and one is chat. Or you could do Alt-H actually. Or maybe I can like, let's see, Tristan. I'll have like, Tristan, you should be able to ask your question directly now.
It's only to thanks, and also to say this thing is more powerful than core dump we analyzed before. Before I was used to analyze core dumps and to see in the syslog what was happening in the system while my program was annoyed in a way or another. So it's very interesting what you do. It's only to say thanks. That's all.
Thank you very much, Tristan. Merci beaucoup.
I have a friend.
Awesome.
Great. Any more questions, anyone? All right. I don't see any other questions coming in. Well, I went a bit faster than expected. Like we're still need to get used to these online formats. Of course, there's less beers and pizza involved, so less chat as well, which is actually a bit of a shame. But yeah, we're trying to organize some like small low-key events just on the pure engagement level, just to have like a chat and keep in touch with everybody. But yeah, thank you very much, both Christian and Alban. It was two very cool talks. And thank you everyone also for attending. Really enjoyed having everyone on board tonight. Yeah, Alex confirms both very cool. Thanks, guys. Thank you very much, everyone. Great job for both our speakers, and wishing everybody a great evening. And see you soon at the next Software Circus.
Thank you.
Thank you, everyone.
Thanks. Bye-bye, everybody.
Bye-bye.